All right, today we're going to be working on starting our section on solutions of systems of equations. Well, you've been used to just graphing one line at a time, but now we're going to be learning how to graph two lines and finding their solution. So if you would please get your journal out, and I'd like you to simply write these two equations down. And we're going to talk about what a solution would be. All right? Systems of equations. So that basically is talking about two equations here. All right, sometimes multiple equations. Sometimes you might have three. But in Algebra 1, we just have two. So if you would, please, in your journal, I'd like you to draw a couple of lines that are parallel. Draw two lines that intersect. And this one's kind of tricky. I'm going to draw a line. I'm going to switch out colors. I'm going to try to draw the same line like right on top of it as best as I can. Now, these are the three scenarios that you could possibly have when you have two lines. Either they intersect perfectly at an x and a y value, and that is what's known as a solution. Now, these lines will always have, obviously, different slopes. So whenever you have two lines that have different slopes, they will intersect at one point called a solution. So this is what's known as one solution. There's only one point where they cross. Now these lines are parallel. Now parallel lines, we talked about this earlier, parallel lines have the same slope. So if they have the same slope, that means there's not going to be any solution. So I'm going to write no solutions. They're not going to have any solutions because they have the same slope. They will never intersect. So any lines that have the same slope, they're not going to intersect. Now, that could be perfectly horizontal lines. They will never intersect, which have a zero slope. You could have perfectly vertical slopes, which is undefined. They have undefined. As long as they're parallel, they have no solutions. This one over here, though, is basically the same line twice. So if you graph a line and you graph the same line on top of it, then it touches it at every single point. So that's called infinitely many. So infinitely many solutions. So you either have no solutions, one solution, or infinitely many. So I'm going to give you some examples of what would be the case if you had parallel lines, say in slope-intercept form. Well, you could pretty much easily see it. So y equals 2x minus 6, y equals 2x plus 2. These lines would never intersect. But it's harder to see it when it's in standard form. So let's say standard form. If you saw 2x minus 4y equals 10 and 2x minus 4y equals 8, you will notice that in standard form, ax plus by equals c, the slope is always negative a over b. And when you put negative a over b for each of these, you see they have the same slope. So here's a scenario where you'd have two lines that turn out to be parallel that would never intersect in standard form. Now, different slopes and slope-intercept is very easy. You can clearly see it. Like if I had y equals 2/3 x plus 1 and y equals x plus 2, these lines would intersect with at one point. You can clearly see the slopes are different. In standard form, you could also see them pretty easily. If I had like 2x minus 3y equals 12 and 2x plus 3y equals 12, you could easily see that these slopes will end up becoming different. So there would be one solution. But right here, this is the scenario where people are like, well, wouldn't it be easy to figure out if they were the same line? Sure. If in slope-intercept form, if I had y equals 2x plus 1, and I just wrote it again, y equals 2x plus 1. But what if I wrote this? 2x minus y equals 1, and I put 4x minus 2y equals 2. Or I put 8x minus 4y equals 4. These are actually all the same line. What did I do here? I just multiplied that by 2. And then here I just took that and I multiplied that by 2 more, multiplied that by 2 more. If I graphed all of these, they would end up becoming the same line. And that's where you get this concept of infinitely many. So these, if I simplified all of these, they would end up becoming, in slope-intercept form, they would all become y equals 2x minus 1. If I move the y over, yeah. So if I simplified all these to slope-intercept form, they would all equals y equals 2x minus 1. Now I'm going to show you in Desmos real quick that what I'm telling you is true. All right, although I can't do test mode, I got to do regular mode. Okay. All right. So if I did, let me look at it real quick. 2x minus y equals 1. And then I did 4x minus 2y equals 2. I want you to see these are the same line, and I told you that they all equal y equals 2x minus 1. So this is in slope-intercept form. These are both in standard form, but this is where it would be infinitely many. They end up being the same line over and over and over again. Now, you guys don't have to do all that for these particular situations in the Khan Academy. All right. So right now, I'm just going to go over how to check your answer right here. It says, is 4, 1 a solution to this system of equations? So we have negative 4x plus 3y equals 2. And then we have 3x minus 9y equals 3. And what we're checking is we're checking to see if 4, 1 will actually work. Now the only way it works is if it works in both equations. So I'm going to take my x value, plug it in for x, and take my y value and plug it in for y. So I'm taking this 4 and I'm plugging it in for x, and then I'm taking this 1 and I'm plugging it in for y. So here's what it would look like. Ready? I'm going to do negative 4, and I'm going to multiply it by a 4 right there. And right here, I'm going to multiply this by a 4. And then here, I'm going to multiply this by a 1. I'm going to multiply this by a 1. So we get negative 4 times 4 plus 3 times 1. So here we get negative 16 plus 3, which equals negative 13. And that's totally not equal to a 2. So this one doesn't work. So I'm going to put a little X mark. Doesn't work. All right. I guess I probably shouldn't put an X mark. But this one doesn't work. So I'm going to say no. No, does not work. So our answer is going to be no. But if we put the bottom one, if I do 3 times 4 minus 9 times 1, see if that equals a 3. Well, guess what? 12 minus 9 does equal 3. So this one does work, but this one doesn't. Now, in order for there to be a solution, it's got to have one solution. Like it's got to have one. It's got to work for both lines. So one of these worked for one line, but it didn't work for the other line. So that's why this answer is going to be. It's going to be no. It's right here. It worked for one, but it didn't work for both. So I got to hit no. Let's do one more real quick, okay? So right here, I have y equals 2x minus 1. So I'm just going to put y equals 2x minus 1. And over here, I have 5x minus 4y equals 1. Now, I got to plug in a 1 and a 1. So that's my x, that's my y. So I'm going to put 1 equals 2 times 1 minus 1. And here I'm going to put 5, plug in a 1 for x, plug in a 1 for y, and see if these work. So here we go. 1 equals 2 times 1 is 2. 2 minus 1 is 1. So this one definitely works. Over here, we got 5 minus 4 equals 1. That works as well. So this one works if I did what? If I take the x value and I plug it in for x, and then I take the y value and plug it in for y and see if they work. So this one's going to totally be yes, they work in both situations. And that's all you guys have to do on this one, is just literally plug them in and see if it's a solution to the system of equations. So if you were to use Desmos, okay? If you were to use Desmos, I can type the first one in. But I can't type, look, I can't type the second one in, 5x minus 4y equals 1. 5x minus 4y equals 1. It doesn't work. So what do I have to do? I have to be able to change this guy to slope-intercept form if I wanted to actually graph it. All right, so in this form, we have 5 as our a value. We have negative 4 as our b value, and we have 1 as our c value. Now, if I wanted to change this to slope-intercept form, negative a over b is the slope. And the y-intercept will always be the c value divided by the b value. That will be your y-intercept, and this will be, that's how you find your slope. So if I want to do negative a over b, I'd put negative 5 over negative 4, and that equals 5 over 4. So there's my slope. If I want to do c over b, I'm going to put 1 over negative 4. So my y-intercept's at negative 1 fourth. So that's my y-intercept. So I'm going to write y equals 5 fourths x minus 1 fourth. There's my slope. There's my y-intercept. Okay? 5 fourths x minus 1 fourth. So 5 fourths x minus 1 fourth. And I want you to see, now look, do you see how the solution is at a 1 and a 1? Now you don't have to do all this to find this answer. You just have to plug in your x and your y and see if they work. All right, so the last thing we're going to talk about is how to graph systems of equations. Okay, so we have two problems right here, or sorry, two equations that are very easy to graph. Okay, these are very straightforward, very easy to graph. The slope in the very first equation is negative 5, which basically means negative 5 over 1, which means you go down 5 and you go over 1, and the y-intercept is at a 6. The second equation, the slope is 3, which basically means 3 over 1, which means I'm going to go up 3 and over 1 to the right. But my y-intercept's at a negative 2. So what I'm going to do is I'm going to take the blue line and graph this one, and I'm going to take this magenta line and graph the bottom one. So see if you can follow along as I do this. See if it makes sense, okay? So right here, my y-intercept's at 6, so I got to put it right there at a 6. My slope's negative 5, so I got to go down 5 units and over 1. 1, 2, 3, 4, 5, over 1. There's my slope, down 5 over 1. All right, now the next one, my y-intercept's at a negative 2, so I put it right there at a negative 2, but my slope's at a positive 3, so I got to go up 3 and over 1. Up 1, 2, 3, over 1. And you see where it hits right there? Now I'm going to go and draw on this so you can see how I got my slope. So I'm going to do the blue slope first, the blue line. So the blue line slope, I went down 5 units and over 1 unit. And then the pink line, I went up 3 units and over 1 unit, and it hits right here. This is what's called the solution. So my solution's literally at a 1 and a 1. And that's what I'm going to type in right here. I'm going to put a 1 right there and a 1 right there. So you have to graph the lines correctly, and you have to write down the correct solution. Okay? Now, this one, what I'm going to do is, I have some multiple choice answers right here, okay? But I want to show you guys how to graph these using their x-intercepts. It's super, super easy, all right? So let's be I'm going to do a couple more of these, and that's it. There's my red one. There's my blue one. So I want you to write this down. Negative 3x plus 3y equals 9. And then right next to it, I'm going to put 2x minus 7y equals negative 14. Now, one thing you got to be able to do, this will be the last problem I do because I got another class coming in. All right, I got to find my x-intercept and I got to find my y-intercept. Now the x-intercept's always c over a and the y-intercept's always c over b. Now this is in the form of ax plus by equals c. So my x-intercept's going to be 9 over negative 3. There's my a value, there's my c value. My y-intercept is going to be 9 over 3. So my x-intercept's at -3, 0, because 9 divided by -3 is -3. And my y-intercept is going to be at 0 and 3, because 9 divided by 3 is 3. Using the same process, I'm going to find my x-intercept and my y-intercept. C over A, C over B. Remember, this is AX plus BY equals C. So I got -14 divided by 2, which is a -7, 0. And then I have -14 divided by -7, which becomes a +2. So I'm going to plot these guys, and we're going to see where they intersect. Just remember, C over A, C over B, get your x-intercept and your y-intercept. This is my x, this is my y. So here we go. -3, 0. -3, 0. 0, 3. There's one of them. And then -7, 0, 0, 2. -7, 0, and 0, 2. All right. Now we got to figure out, okay, where is this point right here? Well, let's check it out. It's definitely between a -1 and a -2. And it's also between a +1 and a +2. So we're looking for a -1. All right, I'm going to choose this guy right here. -1 and 2/5 and 1 and 3/5. That's kind of our best estimate right in there. I'm going to say that's our solution. Okay. So we do a little estimating on this one. If you're not sure what we did, you can go to see step-by-step solution. You can kind of see what there's only one that fits the description. Okay? But always use your x and your y intercepts to practice plotting. Okay? So I'm going to do one more real quick. I'm not going to write all the notes down. I'm just going to do my x-intercept. 24 divided by -8 is -3. So I'll put right -3. And 24 divided by 4 is 6. There's my first equation right up there. 28 divided by -7 is -4, so I put -4. 28 divided by 7 is 4, so I put 4 right there. So if you're wondering, how did I do that so fast? Just take this number, divide it by the -8. That gets your x-intercept. 24 divided by 4 gets your y-intercept. That's the blue line. And I did the same thing for this one. So you can go back and see how I did that if you want to. Now, the ordered pair that's a solution is at -2, +2. So I'm going to put it's at -2 and +2. So that's without writing all the stuff down. That's what you can do in your head. It makes it super easy. And that's it. Good luck. I hope this was helpful, and have a good day.